right, so today we are going to cover permutations. A little bit of an introduction here before we do any notes. Let's say those 6 boys in the last row over there are, okay, all right, okay. Are we all set? All right. Let's say we have those 6 boys in the last row, and maybe we decided to change the order. Okay? So maybe we'll take Anthony and bring him up to why it is why that would be one change. The way it is another way I could organize it. Then maybe I'll take Alex and Jim and switch those two. That's another way. Then I'll take John and I don't know, John and Nate, switch them. Then I'll move Nate to the front. Move Anthony back. That's another way. How many different ways can I arrange? Okay? So, let's look for a pattern here. If we had 2 people, how many different ways could we arrange that? Well, I could arrange it as A, B, or BA, right? So that's fairly simple. So 2 different ways. If we had 3 people, we could arrange it as ABC, ACB, BAC, BCA, and then put the C out front, and we'd have 2 ways for the C, CAB and CBA. Well, if we keep going with this pattern, we would see that this would be 2. This would be, if we have 3 things, 3 times 2 would give me 6. The next one with 4 would be 4 times the 3 times the 2. And so we start to build this pattern. Well, if we have 6 distinct objects, all those boys are distinct objects. They're not the same boys. And so we can do this that many ways. This is read 6 factorial. 6 factorial. That's the way we read that. We don't read it as 6. 6 factorial. And what this means is 6 times 5 times 4 times 3 times 2 times 1. And there's 720 different ways I could arrange those boys. 720 different ways. These are called permutation. All right. Take the letters in my name. How many ways could I arrange those letters? 720. 6 factorial. Okay. Let's take somebody's name in here. It has to be a certain name. Let's take John. John, is your first name Jonathan?
Yeah.
You know what? I think I'm going to make these all capitals so that it doesn't really matter, but is it B-A-R-R-Y or E? All right, now, how many ways could I arrange those letters? Now, this one is a little bit different. Okay, this one's just a little bit different. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's a big number. In fact, I don't even know if your calculator will handle that, but I think it might. 18 factorial ways, except we have some repeats. And how do I know? I mean, take these two R's and flip them around, because that would be a way. Does that really count? No, because it would still be RR, right? So what we have to do, if we have some repeats, is we're going to divide by the repeats. So let's just see what we have. For the n's, I have 1, 2, 3, 4. I have 4 n's. So I'm going to divide by 4 factorial. And we have, let's see, 1, 2, we have 2 O's.
One of those O's should be an A, but John Ethan.
That's okay. Just for this should have been an A?
Yeah.
Okay. We have 1, 2, 3 E's. We have 2 R's. Is there anything else? Yeah, we're not going to change that, but I think I've got everything, don't I? The 2 E's? No, I got 3 E's. That's this one. 2 H's? All right. Now to do this in your calculator, here's what we do. We're going to put 18. In order to get to the factorial, we go to our math button, the first column. We scroll over to PRT, probability, and that's the menu that we're going to be using this chapter. We scroll down to number 4. Okay, and we enter on that. And then divide by that. If you're going to put all these numbers in the denominator, you have to use parentheses. But sometimes it might be easier to do it this way. I know that 2 factorial is 2, 3 factorial is 6, 4 factorial is 24. It might be easier, rather than to go to your menu and hit all the factorials, 24 times 2 is 48, times 2 is 96, times 2 is 192. Now you have 192 times 6. And maybe that we can put in our calculator. All right, if we don't know what that is. And I believe it's 548, but let's see. It is. Divided by, I'm going to use parentheses, 6 times 192. And that's a pretty big number. Unfortunately, I picked a number with, or a name with a lot of letters in it. But it comes out to about 5.56 times 10 to the 12th power. That's how many different ways I could arrange his name. All right? Which I think it's over 55 billion, I think. Okay. All right. And obviously, if we took something a little bit simpler, maybe we took Mississippi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 factorial divided by all the repeats. We have 4 S's, 4 factorial. We have 4 I's. And we have 2 P's in a pod. I don't know. It's an old, from Laurel and Hardy. You guys are too young. Anyway, all right. And so that would maybe give us a number that would be a little bit easier to understand. Okay? So we would have 24 on the bottom times 24 times 2, or 24 times 48. And I think that's something that our calculator would be able to handle. We had 11 go to the math program, probability, 11 factorial, divided by, in parentheses, I'll hit 48 times 24. And that's 34,650 ways I can arrange the letters of Mississippi. I had to divide by the repeats. Okay? But if we're just taking those 6 people in a row, and how many different ways could I arrange those boys in a row? 720 different arrangements. It's kind of hard to believe, but it works. Okay? Factorial. If I took those same 6 boys and we arrange them sitting around the table, sitting around the lunch table, how many different ways could I arrange them? Well, there's a formula for what we call a circular permutation. All right? We have 6. Well, this would be n minus 1 factorial. So if it's in a circular arrangement, this is the formula for a circular permutation, circular arrangement. And it is less. It is 6 minus 1, or 5 factorial, which is 120. And the reason why it's less, see if you can imagine this. If I take this circle and I turn it 1 click to the right, that would be a different arrangement if they were in a line. But if they're in a circle, it's the same order, isn't it? All right? So it'd be a little bit less. If you had a, maybe at, you go to Kroger and you order for a party, you order a vegetable tray. You've seen these vegetable trays, and maybe there's 8 vegetables around the end, and in the middle, there's a dip. Okay, no offense. All right. And then all around here we have 8 vegetables. And so Kroger says, well, how do you want those arranged? And you might say, well, how many different arrangements are there? Okay, well, if you have 8 different types of vegetables in a circular arrangement, it would be 8 minus 1 or 7 factorial. And I think 7 factorial is around 5,040. Hard to believe, but there's 5,040 different ways that we could arrange those vegetables around the dip. Okay. All right. Circular permutations. We're not talking about probability. This hasn't got anything to do with yesterday's assignment. This has how can we arrange different things. All right. Okay. Let's take another scenario here. Let's take let's take an iPod. And let's say on this iPod, I want to take numbers that are small enough for us to deal with. So let's take an iPod that has 15 songs on it. And I want to listen to 3 songs out of the 15. All right, how many different ways can I listen to those, to 3 songs? All right. So maybe there's song 1, maybe I take song 1, 2, and 3. Well, that would be another arrangement would be 2, 1, 3. Maybe I want to listen to song 3 first. 3, 2, 1. Okay. And there's 6 ways I could listen to those 3 songs. How many different ways? Well, there's a formula for this. I have a total of 15 songs. The total is, you take the number of songs, n factorial, divided by n minus r. Let me write this top n printing. Factorial. Okay? So this would be 15 factorial divided by 15 minus 3. R is the number of songs we're going to listen to. Okay? N minus R, or 15 minus 3 factorial, or 12 factorial. Here's what we can do here. We can go 15 times 14 times 13 times 12 factorial, 12 all the way down, divided by the 12 factorial, 15 minus 3. And now the 12 factorials will reduce. And so it's 15 times 14 times 13. And that would be 2,730. Different ways. Maybe I take number 1, number 12, and number 14. Okay, then I've got 6 ways I can listen to those. All right? Okay? All right. All right, so in your calculator, we have something that will take care of that. And that is a function in your calculator that reads n. Remember, n is the total number we have. P, permutation. The permutation is when order matters. Taken R ways. All right? So in your calculator, we're going to enter the number 15. We're going to go to your math. And by the way, if you scroll left one, it'll go right to the end there, probability. And then scroll down to NPR, enter on that. So we have 15, NPR 3. And this is when order matters. Okay, does that make sense? In this class, right now, we have we have 33 people in this class right now. And we just had student council elections, didn't we? All right. Suppose out of this class, I want to take a president, vice president, secretary, and treasurer. How many ways can I take the president, vice president, secretary, and treasurer? Maybe I want to take these 4 girls over here. All right? Does order matter? I mean, we could be president, vice president, secretary, and treasurer. Or maybe it would be president, secretary, vice president, treasurer. Or president, treasurer. So there's a lot of combinations for those 4. Order would matter. Which one's president, which one's vice president. This chapter, you're going to have to make a lot of, you're going to have to read the problem and you're going to have to do a lot of figuring out what are they talking about here. Okay? Does order matter? If order matters, then we're going to do this permutation here. So we're going to take 33 NPR 4. Okay, so we go to our calculator. I think I'll hit second enter, and then I'll put 33 in place of 15, and I'll put 4 in place of 15. And so there are $982,080 different ways that could take 4 people out of this class and have a president, vice president, secretary, and treasurer. Okay, you guys get the idea? Right. All right. Some of these get a little bit tricky, especially the challenge problems, but you should be able to figure it out because you're smart. So on page 640, 641, I want you to do problem 9 through 48, thirds, and problems 49 through 62, all. Okay? And we can work on those after lunch.